I want you to take a look at this map here. I know it's all over the place, but it basically shows some of Earth's major and minor tectonic plates. But what I want you to focus on is this long line right here. This line is known as the Mid-Atlantic Ridge, and it separates the North American plate from the Eurasian one. Do you notice though that this line goes right through Iceland? This means that Iceland sits on two tectonic plates, something that almost no other country in the world does. Now, being located here is extremely advantageous for Iceland, because it gives them access to more geothermal energy than the country of just 360,000 people will ever need. Let me explain. Basically, these two tectonic plates are divergent, meaning they are pushing away from each other, and at a rate of 2.5 centimeters per year. As these plates pull apart, there is a natural pull that forces the flow of magma from the mantle to the Earth's surface through the opening. This photo here illustrates it pretty well. Iceland is essentially located on a hotspot, where magma is especially close to the surface. I mean, that's basically how the land of Iceland formed here in the first place. And it's the same reason why Iceland has so many volcanoes, geysers, and hot springs as well, not to mention a third of the Earth's total lava flow. But the journey from having the potential to produce tons of geothermal energy to doing so was born out of desperation. We'll get to that in a bit though. If we look back at Iceland's history, we would see that Icelanders have been using hot springs to wash their clothes and bake ferrabrauð, or hot spring bread, for hundreds of years. But the first realization of its potential came in 1907, when one smart farmer realized that he could use the same steam that baked ferrabrauð to heat his house. He built a large concrete pipe that connected a hot spring beneath his property to the inside of his house, directing the steam from the underground spring into the rooms of his home to heat it during the cold winter months. Unsurprisingly, the idea caught on, and a couple of years later, a different farmer found a way to use steam from a similar hot spring to heat his own water at home. By 1930, Iceland's capital Reykjavik's first geothermal district heating system was created, when a school, hospital, swimming pool, and about 60 residential buildings were connected to geothermal energy. As time went on, geothermal energy slowly became more and more used. In the 60s, the government of Iceland came up with a legal framework for a geothermal fund. The goal was to provide low-interest loans for geothermal research and test drilling, and for any failed projects, the loans turned into grants and didn't need to be repaid. But despite all of this, Iceland still relied on coal and oil for 75% of its energy. Everything changed though during the 1970s oil crisis. By the start of the 70s, the majority of Western countries, including Iceland, had become super dependent on Middle Eastern oil for the majority of their oil supply. Everything changed in 1973 when the Organization of Arab Petroleum Exporting Countries declared an oil embargo in response to the US decision to resupply the Israeli military during the Yom Kippur War. Naturally, European countries were also hit, and like many other countries, Iceland couldn't sustain itself through the oil crisis, as it was still a developing economy and relied on resources from other countries, especially given its isolated location on the edge of the Arctic Circle. Iceland was in desperate need of a stable and economically feasible source of energy from within the country itself, and geothermal energy was a solution to this problem, with the idea only being solidified further and more urgently after the 1979 oil crisis following the Iranian Revolution. As a result, if you look at this graph here, you'll see it only took 12 years to decrease oil for heating from 50% in 1973 to 5% in 1985. Or this graph here, you'll see the first major jump came from 1970 to 1980. And now that brings us to today. 99.96% of Iceland's electricity is produced by renewable energy, with 26.96% being geothermal energy and 73% hydropower. Geothermal heating supplies nearly 90% of the nation's domestic heating and hot water requirements, with less than 0.1% from fossil fuels. The biggest plus though is that with geothermal capabilities, you can produce lots of energy that is always available with high reliability. And unlike fossil fuels, there is virtually no release of carbon dioxide, causing harm to air quality. If you had to make a comparison, you could say that geothermal energy used for heating homes across most of Iceland in a single year is equivalent to the heat obtained from the burning of 646,000 tons of oil. Assuming this, based on the government's estimates, the total release of CO2 in the country is cut by nearly 40%. Then there's the money aspect. The amount of money Iceland is saving with this is insane. The government believes that exploiting geothermal energy for space heating alone saves Iceland $100 million in imported fossil fuels each year. Looking at this from a distance, switching to geothermal energy has saved the country an estimated $8.2 billion over 30 years. And you know what the craziest part is? Given active volcanic zones cover a quarter of Iceland, with eruptions occurring every 2 to 4 hours, only 20% of the geothermal potential available for electricity production has been harnessed, meaning there's an unimaginable amount of other things that Iceland can do with the remainder of it. However, the biggest impact of geothermal energy on the economy of Iceland is actually in the tourism industry more than anything else. Take for instance the Svartsengi power station. Not only is this one of the most important geothermal power plants in all of Iceland, but it's also the reason for the creation of, and fully powers, Iceland's most famous tourist attraction, the Blue Lagoon. This unique and picturesque world-famous geothermal spa is Iceland's most popular tourist destination by far, and it's all powered by geothermal energy. Just to put its attraction in perspective, remember when I said Iceland's population is just over 360,000 people? Well, more than 1 million tourists visit the Blue Lagoon annually. That's over 3 times the population of Iceland. But the story of Iceland's geothermal domination doesn't end there. In fact, it's being taken a step further. So Iceland has quite a few geothermal power plants, each consisting of multiple wells that tap into the country's underground heat. The thing is though, most of these are relatively shallow. If you really want to make the most of the abundant natural energy supply, you need to go much deeper. Scientists are drilling experimental wells nearly 3 miles into the earth, twice the usual depth of Iceland's geothermal wells, to try to tap into superheated water. At what's called supercritical temperatures, seen above 750 degrees Fahrenheit, water and steam merge into a single supercritical fluid. It has the potential to change everything. A typical Icelandic geothermal steam well produces the equivalent of 5 megawatts of energy. A supercritical well could produce 10 times that. This means that just 3 or 4 wells could heat an entire city. But of course, the cost of this isn't really economically feasible currently, and at such insane depths, the technological tools just end up melting. It's still the future though, don't get me wrong, and Iceland is the one leading the way. So now, the Icelandic government has plans to take their knowledge and experience much further, even outside their own country. They've participated in geothermal projects in over 50 countries, and continue to be highly active worldwide. They've partnered with the United Nations Environment Programme to work with countries in East Africa to harness their own geothermal energy. These countries, including Ethiopia, Kenya, and Uganda, sit on top of the Great East African Rift System, a fault line similar to the Mid-Atlantic Ridge that Iceland sits on. Meanwhile, Iceland's third largest bank, Glitnir, helped finance the world's biggest geothermal district heating project in the city of Xianya, China, serving over 1 million people. Despite all of the progress Iceland has made though, there's still work to be done given their goals of reducing carbon emissions by 55% by 2030, achieving carbon neutrality by 2040, and becoming among the first nations to be free of fossil fuels completely. Though I don't think that'll be hard for them. It's not so much a question of if, rather than when. Thank you for watching.